Hello everyone, I hope everybody is fine. In this lecture, we want to talk about domain and range of a function. The domain of a function is nothing but a set. A set of numbers is what a domain is. But what kind of set of numbers? The set of numbers for which a function is defined. In other words, the set of all first coordinates of the ordered pairs in a function, or simply the set of valid input numbers for a function. And the range, which is another set, is the set of all possible resulting values of the dependent variable y after substituting all possible x values. In other words, the set of single output numbers. So the set of input numbers for a function, valid input numbers for a function, is the domain set, and the set of the single output numbers for the function is the range set. That's what domain and range are. There are two sets of numbers. In this lecture, we will concentrate on domain for now. So we have a cubic function here, y equals 4x cubed minus 5x squared plus 2x minus 1. And this is a cubic function. We want to know what the domain of this function is. We know that the domain of all polynomial functions, whether they are cubic or not, whether they are quadratic or not, even linear functions, quartic functions, quintic functions, or even an nth degree polynomial function always has a domain as the set of real numbers. So I'm going to say the domain at letter D of function f, d sub f equals the set of, open brace brackets, numbers like x, okay, that's the input number, x represents the input number for the function, belonging to the set of or is an element of. That's the meaning of this symbol. So x belongs to the set of, or you can read it as x is an element of the set of real numbers. So that will be the domain of this cubic function. You can write the answer in interval notation by saying that x belongs to this interval of negative infinity up to positive infinity. And of course, it's an open interval by definition. So that's domain of this cubic function. Basically, any real number you select can be a valid input number for the function, basically. And the function is defined for all real numbers, basically. There's absolutely no restriction involved. Next one is an absolute value function which has undergone some transformations. We see a vertical stretch by a factor of 3, horizontal shift to the right by 5 units, and vertical shift up 4 units. But it doesn't matter if you transform an absolute value function or not. Its domain is not affected. So we're going to say the domain of this absolute value function is the set of real numbers. Another way to show this. Or again, as interval notation, you can write the open interval between negative infinity up to positive infinity. That is the domain of this absolute value function. Next one is an exponential function, which of course the basic function 2 raised to the exponent of x has undergone a horizontal shift to the right by 1 unit and then a vertical shift down 8 units. But again, it doesn't affect its domain. It definitely affects its range when the graph is vertically shifted up or down, but it doesn't affect its domain. So whatever the domain of the basic exponential function y equals 2 to the exponent of x is, the same domain applies here as well. So domain, again, is the set of real numbers. This one is a square root function, which has undergone some transformations, obviously. But the thing is that in case of square root functions, the radicand, which is the expression under the radical sign, must always be either positive or 0. So it cannot be negative. So this means that 3x minus 6 has to be greater than or equal to 0. This is a restriction involved because nobody can take the square root of a negative number. So even if you try to use your calculator and find the square root of negative 4, you will see the error message on the display of the calculator. So this means that 3x has to be greater than or equal to 6. In other words, x has to be greater than or equal to 2 after you divide both sides by 3. Therefore, we're going to say the domain of this function is the set of all numbers like x belonging to the set of real numbers such that this is another vertical line, which is a symbol, mathematical symbol. It is read as such that x has to be, of course, greater than or equal to 2. So mathematics is a language. Mathematics is a language, and obviously, just like other languages, it has its own symbols. Like French has its own symbols. Music has its own musical notation and symbols, like treble clef, bass clef, all of that. And every language has its own symbols. Mathematics also has its own mathematical symbols. Now, I wrote the domain using mathematical symbols. I'm going to read this as an English statement for you. Are you ready? So I'm going to mention a long English statement, which is a translation of this mathematical expression. So the domain of function f equals to the set of numbers like x belonging to the set of real numbers such that x is greater than or equal to 2. So that was an English sentence. But if you want to write that down, it's going to take like 3 lines. But using mathematical symbols, mathematical notation, you can just communicate your thoughts in short form. Okay, so that's the domain of the square root function. This is another square root function, but the restriction is the same. In fact, to make it more interesting, I'm going to make this fourth root, okay? So this is a fourth root of 4 minus x squared instead of square root. I made it fourth root, but it doesn't matter because even if you have a fourth root or sixth root or eighth root, as long as the number in the index of the radical is an even number, you can't have negative numbers under the radical sign. So again, we're going to say 4 minus x squared has to be greater than or equal to 0. And that means that x squared has to be less than or equal to 4, obviously. And that dictates that x has to be between 2 and negative 2. So x is trapped in between 2 and negative 2. Because imagine if x is like 3 or 4, then 3 squared or 4 squared is not less than or equal to 4. So x has to be either 2 or less than 2, such that when you square it, you end up with an answer which is less than 4. So that's why we say x is trapped in between negative 2 and positive 2. Now, officially, we always communicate using mathematical notation. X belongs to the set of real numbers such that x is greater than or equal to negative 2, at the same time less than or equal to 2. Moving on to the next type of function, this is a rational function, or you may say it's the basic reciprocal function, which has undergone 2 transformations, one vertical stretch by a factor of 2, and one horizontal shift to the right by 9 units. By the end of the day, the denominator cannot equal to 0. That is the restriction we have in rational functions. So this means that x cannot equal to 9. So we're going to say the domain of this function is the set of real numbers such that x can be any number other than 9, of course. Okay? Because if x is 9, think about it, the denominator becomes 0, and 2 divided by 0 is undefined. You can't even find the answer using your calculators. So x can be any real number, positive, negative, fractions, decimals, whatever you want, except one single value, which is 9. And that is the domain set of this rational function. That is the set of valid input numbers, because 9 is not a valid input number. Okay, this is a logarithmic function which has undergone some transformations, a horizontal shift to the left by 2 units and a vertical shift up 3 units, clearly. It's a logarithmic function y equals 3 plus log base 4 of x plus 2. And in logarithmic functions, we know that logarithm is defined only for positive numbers, period. 0 and negative numbers do not have any logarithm. So here the restriction would be x plus 2 greater than 0, not even equal to 0. Because if it is equal to 0, log of 0 is undefined. So this implies that x has to be greater than negative 2 So we're going to say the domain of this function is all real numbers such that x has to be greater than -2. And that is the domain of this logarithmic function. Another rational function, another denominator, which we have to set it not equal to 0. If you factor it, you get x times x squared minus 4, right? And then that would be a difference of squares. If you factor x squared minus 4, so x minus 2 times x plus 2, this cannot equal to 0. And that means that x cannot equal to 0. It cannot equal to positive 2, and it cannot even equal to -2, because if x is 0 or 2 or -2, it would make the denominator equal to 0. As a result, the function becomes undefined. So we're going to say the domain of this rational function is all real numbers such that x cannot equal to 0 and x cannot equal to plus minus 2. But other than that, it can be equal to any number that you mentioned. That is fine. We can also write this in the form, the set of real numbers minus another set which has only 3 elements, 0, 2, and -2. So we are saying that the domain is a set of real numbers here, but then we're subtracting 3 elements in this next set. We're subtracting 3 elements, and we write those 3 elements in the form of a set. We're saying that if you subtract that set with 3 elements from the set of real numbers, the remaining x values would be elements of the domain of this function. Sine function, cosine function, both of them have a domain of set of real numbers. You can even find a sine of 1000 degree angle or cosine of 2000 degree angle. Your calculator can give you the answer, not an issue. So here we're going to say the domain is actually the set of real numbers, and we have no issues to report. Remember, I said domain, and it's not about the range. Okay. I hope you understood how we find the domain of different functions. And in a separate lecture, I will discuss the range. Okay, just remember, for square root functions and functions, radical functions with even order, like 4th root or 6th root or 8th root kind of functions, the radicand must be positive or 0. And in case of rational functions, denominator cannot equal to 0. Okay, and if you have like logarithmic functions, the argument must be positive, not even equal to 0. And for other cases, we don't have any restriction. Thank you, and keep practicing.